Hello, everybody. My name is Ethan Arrowood. I'm a software engineer for Microsoft, and today I'm going to be talking to you all about safely handling dynamic data with TypeScript. So, handling data. What is data? Well, as software developers, we use a lot of it, and in a lot of different ways. Some good examples, at least of how I use it, is within API routes when building a backend service, dealing with forms on the front end, and also authentication payloads and all of the surrounding things that go with authentication in an entire full stack application. And this is just a short list. You can only imagine how long this can get when you start dealing with databases or data science and just general any sort of communication between large systems. So let's take a peek at an example of a record or a chunk of data. In this case, I'm using a JSON object. We got a bunch of keys here: ID, name, employed, company, age, and projects. We're representing a person. Maybe this is an employee directory, or maybe it's a user directory for a site such as LinkedIn, where we have a user, we want to give their name, we want to know, are they employed or not, which is a Boolean value. We want to know what company they work for, and we want to know how old they are, and we also might want to list their projects. And as many folks know, JSON is a very verbose way of representing data. It has a lot of great primitives that are all based in JavaScript, and it can be quite extensive. In fact, entire APIs are powered by just JSON objects alone through the open schema format. So talking about backend APIs, let's take a look at a Fastify route. In this case, we're defining a post route. The path is add user, and the request handler here has two arguments: request and response. And we're destructuring the body from that request object. Does anyone know what type body might be? Is it a record, an object? Is it any type? Trick question. It's unknown. The body property of that request object, taking a peek again at the code, the Fastify route has no idea what it is, because in context of Fastify as a framework, we're not sure what the developer intends to be coming in through their request. And there's no way for Fastify to know that when the code is being written or even compiled. Well, maybe not when it's compiled. We'll get to that later. So let's take another look here. Looking at the previous JSON object, or take a slice of it, just look at the ID and the name. There are strings, string keys and string values. And then looking at the post route again, we know that body is unknown, that we're destructuring from the request object. So what would be body.name? In this case, imagine that the JSON object is being sent to this route as the body in the post request. So what would name be? Probably string, right? Well, a trick question again. TypeScript will throw an error. Object is of type unknown. Why is that? Well, it's because the body property is coming from that request object. Because it's unknown, no other types can be derived from it safely in TypeScript. TypeScript goes, no, stop here. I don't want you to keep going and using properties on this object, because as the TypeScript compiler, I don't know what it is. And I can't provide you the type safety that you're looking for. So even though as a user, we might think, the name property, it's always going to be a string. There's no ifs, ands, or buts about it. In this case, TypeScript's like, well, you didn't tell me that, and I have no way of assuring that. So there's some patterns we can use. You can use basic typecasting, where we could say body.name as string, and we will tell TypeScript it's a string. But in that case, there is no verification. There's no way of saying that assuring that that name property is actually a string, because TypeScript is a compile time only type safety. During runtime, it's all just JavaScript. There is no type safety at the runtime. So what are some other solutions? That's where I want to introduce JSON Schema. JSON Schema is a super powerful API. It lets you define a JSON object with more JSON. Isn't that just wonderful? Kidding aside, JSON Schema is actually incredibly verbose, even more verbose than the JSON objects that it's probably defining. JSON Schema uses a standard or a specification to allow a developer to define the shape of a JSON object, given things such as the type, listing the properties, saying what properties are required or not, listing if there are additional properties or not, and even being able to define more complex types. As you can see in the code sample, the projects property is of type array. And then we get to go even further and say the items of that array are of type string. JSON Schema, and this only scratches the surface of JSON Schema. You can use regular expressions, you can use references, you can use logical operations like all of or any or some, and it's just so powerful when you leverage JSON Schema to define your JSON objects. So all that said though, JSON Schema, I think it's even in their spec, is intended for validation. The validation in a sense of, here's a schema and here's a JSON object. You give that to a validator and you say, make sure that my JSON object is actually what I'm saying it's supposed to be via the schema. Throw an error or give me some special output if it's not. So with that, we have our JSON object, that payload from before in one hand. We now know that we can define a schema for it in the other hand. So going back to the Fastify application and that route, are we able to provide any type safety yet? Not really. All we can do is validate that that incoming body is what we want it to be using JSON Schema. But come on now, it's 2021. There's some pretty cool things we can do. So let me introduce you to TypeBox. TypeBox is a fantastic library that allows you to not only define JSON schemas using a Fluent-like API, but also derive a static type of that JSON schema in your TypeScript code. So given this very basic example, you can see on the second line, constant t equals type.string. That is going to return type.string, an object with one property, type, that is set to string. This is a valid JSON schema object. We are saying that the variable t is the JSON schema type string. And we can use that JSON schema that is assigned to variable t in anywhere that we would use JSON schema, in any sort of validation or serialization level. But then on that last line of the sample, you can see type t equals static, and then the generic parameter type of t, which is that constant declared on the second line. And now that type t is a string. The TypeBox library is smart enough to derive the type from a JSON schema into that static shape. And so at a more complex example, let's redefine our body schema using TypeBox. You can see we've started with type.object, and then we've listed our 6 properties, ID and name are type string, and then employed, company, age, and projects are all just type optional. And then within those optional types, we define, type Boolean for employed, string for company, number for age. And in projects, you can see we're doing type string inside of type array, which is the TypeBox way of saying an array of strings. And then we're defining a type, T-body schema, is going to equal the static resolution of the type of that TypeBox body schema. And then in the final block of this code, fastify.post, you can see we've now used a generic parameter. It's a object, a name. I like to call them name generic parameters. And we've assigned that T-body schema type to the body property of that generic parameter. The Fastify type system will forward that T-body schema type through to the body property of the request object. And so that's great. Now we've typed the body property of the request object, but we're still missing a key step here, but this code already solves it, is the validation step. As you can see underneath the add user string, there's another argument added to this route, and it's schema, and then the object body, and then it's the body schema. And don't get confused, that body schema is the actual JSON schema returned by TypeBox's API. Fastify has this schema option, which allows the developers to verify the incoming data of a request and the outgoing response shape using JSON schema. Under the hood, we pass that to AJV, another JSON validator, and we validate the content based on the schemas provided. That validation step happens before that handler function executes. And so if the validation step fails, if the incoming request body doesn't match the schema that we've set it to in that second function argument, then the entire route will error and return an error to the user saying, invalid body. And then I think it also includes the JSON validator error as well. And with that all together, inside of our function handler now, by the time Fastify gets there, we can think, okay, Fastify has validated the body property of the request object using the schema we've defined using TypeBox. We've also provided the type for that body property using the generic parameters. That is a type that is derived directly from the same JSON schema used to validate that property. And so now inside of our function handler, that body property from the request is going to have the T-body schema type. And then accessing something like body.name will in fact return a type safe string. And if you're accessing one of the optional properties, it'll be that type. In this case, body.age would be number, or it's undefined. And this is like my favorite part about all of this. But it also sort of breaks down a little bit of the whole kind of problem in the first place, where TypeScript is a compile time only type safety, not runtime based. And so when you're inside of a route handler and you're taking that body from the request object, if we forget about the fact that Fastify is going to validate our incoming data for us, you have to remember that you can unsafely just say body is this type and then go about your business in your route, and that's kind of it. There's no actual true type safety there. But with the validation layer that Fastify adds, we can get as close as possible to type safety for highly dynamic data. Because if we put a hard line, or if we trust Fastify enough to be like, this route handler will not execute if the validation step doesn't succeed, then we can tell TypeScript confidently that the type of that property inside of that route handler is going to be what we want it to be, what we think it's going to be, because we trust in that validation step. If that validation step logically is incorrect and will let through something that we aren't prepared for, then we're going to have a problem. And unfortunately, even a JavaScript application wouldn't be able to sort of respond to that. it will probably have to error out if you're trying to access a property that doesn't exist because it somehow gets around the validation step. So all in all, JSON schema plus TypeBox plus Fastify is super, super powerful. And I briefly want to jump over to VS Code and show you all this in sort of real time so that you can get an understanding of what it actually will look like in a real Fastify application. So in my Fastify app here, I have this basic run function that's going to create a new Fastify app. We're going to register our create server plugin. We're going to do await app.ready, get the address, and then print some nice things out to the console. Over here on the server, you can see we've imported that TypeBox API. We've defined our body schema, and you can see it has this really interesting shape. The type of body schema is a TypeBox T object with a generic of this named generic parameters, where the first property ID is of type T string, name is of type T string, employed is of type T optional with the generic parameter T Boolean, and so on and so forth. In fact, the projects one gets cut off, but it's going to be T array T string. And we can sort of hover over that by seeing, okay, what would this projects be? You can see in the IntelliSense, it's T optional, T array, T string. Generics are crazy powerful nowadays. And you can see down here, this in the type T body schema, it's kind of looking kind of funky. We have empty object and, we have empty object and empty object and object, optional employed, optional company, optional age, optional projects, and then and another object, ID and name. Going down into our Fastify route, you can see we're passing that body schema that is defined here. It's an actual JSON schema to the body property of our schema parameter here for Fastify. And in this post generic, we're passing that type T body schema. And if we hover over body inside of the function handler itself, you can see we're getting that static object type, and it passes that same generic named generic parameter that comes from body schema. And now when you do body.name, you get type string. And if you do body.age, you're going to get number or undefined. And so inside of this function handler, you can now most confidently rely on the type safety of your dynamic data that is all based on the same JSON schema that is being used to validate it at the same time. So jumping back over, I want to say a big shout out to the Undraw graphics illustrations collection. Without it, my presentation would be way more boring. And also, this whole thing was built with Highlight.js and the TMCW Big library. I highly recommend it if you yourself are working on a presentation. And I want to say a big thank you for attending my talk today. I hope you learned something, and I hope to answer your questions in a little bit. If you'd like to follow me on Twitter, there is my thing. You can also follow me at GitHub as well. I love to connect with folks. I love talking about Node.js and TypeScript. And yeah, I hope to see you all around. Thanks again.